My second example of a system with three variables, you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? So first thing, we need to figure out what our variables are going to represent. And as I said in example 2a, if you're not sure, look to the question because that'll help. It says, how many of each type of shirt should you buy? Each type of shirt, those are going to be our variables. And we have three types here, so we have three variables. Let's use X to represent the number of t-shirts, Y to represent the number of polo shirts, and Z to represent the number of rugby shirts. Then we can look for our similar information. Let's look at our budget first, budget of $6,000. And let's see, t-shirts are $12 each, polos are $24 each, rugby shirts are $36 each. Put all of these dollar values together to come up with one equation in our system. All right, so again, t-shirts are $12 each, so that's 12x, plus polos are 24, so 24y, plus rugby shirts are $36, 36z equals our $6,000 budget. Then all together, we are restocking 200 shirts. So that's our total of our t-shirts, polo shirts, and rugby shirts added together. That's x plus y plus z equals 200. And then finally, we want twice as many rugby shirts as polo shirts. And again, it's really easy to get your variables switched from what you really mean. So sometimes it might help to just think of numbers for a second. So let's say we have 10 polo shirts. We want twice as many rugby shirts, so we'd have 20 rugby shirts. So the number of rugby shirts, which is Z, we find by taking 2 times the number of polos. And together, here's our system. So just like in example 2a, I have Z equals 2y. I have one variable by itself with only one other variable on the other side. So substitution actually works really well here. And it tends to work pretty well with word problems. Not all the time, but a lot of times word problems are kind of nice with substitution. So I'm going to take this Z equals 2y, and everywhere I see a Z in my other two equations, we're going to put 2y instead. So this blue equation, and I'll stick with my color coding here, I'd have 12x plus 24y plus 36z, but instead of a z, I have 2y equals 6,000, and simplify what we can. So 12x plus 24y plus 36 times 2 is 72y. This is 96y altogether. And one thing that I notice here is that all of these numbers, all of my coefficients and constants are divisible by 12. So I'm going to go ahead and do that. If I divide both sides by 12, I'd have x plus 96 divided by 12 is 8. And 6,000 divided by 12, well, 60 divided by 12 is 5. So 6,000 divided by 12 is 500. And then let's also plug our z equals 2y into our middle equation here, the green one. And have x plus y plus z is 2y equals 200. Y plus 2y is 3y. X plus 3y equals 200. So this is my system now that I will solve together, my system with two variables. Line those on top of each other. And the fact that we took this 12x plus 96y equals 6,000 and divided both sides by 12 is really helpful here because now I have an x in both equations, and these are going to be able to eliminate very nicely. X and x, I have the same coefficient. To get these guys to cancel, I have to subtract my equation straight down. X minus x cancels. 8y minus 3y is 5y. And then 500 minus 200 is 300. Divide both sides by 5. We get y equals 60. All right, so I know y equals 60. Y equals 60, and z equals 2y. Z is going to be 2 times 60, which is 120. And then my other equation right here in the blue, I could use the blue, but the green would be way easier. X plus y plus z equals 200. I don't know x yet, but I know y is 60. And I know z is 120. Altogether, that's 200. So I have x plus 180. Subtract 180 from both sides. X is 20. So altogether, this is saying we should sell 20 t-shirts. Or we should buy 20 t-shirts. 60 polos. And 120 rugby shirts.